Good afternoon. We are going to do the notes for 7.2, which are properties of proportions. All right, number one, definition of a proportion. Let's review that. It is an equation stating that two ratios are equal to each other. And this is sometimes the generic form of a proportion. The top two terms, which in this are a sub 1 and a sub 2, have the same units or the same topic as each other. The bottom two terms, b sub 1 and b sub 2, also have the same units or the same topic. So an example would be 3 pencils to 2 hours equals 9 pencils to 6 hours. Both of the top ones are in terms of pencils, the bottoms are hours. Another one would be in dollars per page, dollars and dollars on the top, page and page on the bottom. The top and bottom, A sub 1 and B sub 1, can have different units if it's a proportion. Ratio, they cannot have different units. In a proportion, they do. So the proportion here is red. A is to B, and then the as is the equal sign, as. C is to D. That's how you read it. The same proportion in colon form, A over B becomes A colon B, equal sign, and then C over D becomes C colon D. Top number over bottom number. Top number comes first. A three-piece proportion, F to G to E, means F over G equals G over E, which equals F over E. The three ratios are equivalent to each other. Okay, extended proportions. Extended proportion is when three or more ratios are equal. So this is an example one is an extended proportion in fraction form. To change this to colon form, you just put A colon B, and then a colon separates the next one, C colon D, and then a colon separates the next one, E colon F. Let's do another one of these. Example 2 in colon form is 3 colon x for 3 over x, colon 6 colon 2x for the middle, colon again, 9 colon 3x. So notice that all of these equal what we call simple ratios. These three, 1, 2, 3. These second two will reduce to 3 over x. They are all equivalent to each other. So 3 possible equations come out of this. If you need this to solve, you can solve the first two as an equation. You can solve the second two as an equation, or you can solve the first one and the third one as an equation. So there are 3 possible equations that you can use to solve when given an extended proportion. Okay, moving on. The means of a proportion. The means of proportion. The means are the middle two terms of a proportion. In fraction form, the middle two are those two. In other words, B and C. In colon form, it really is the middle two, which in this case is T and 5. Means starts with an M, middle starts with an M, so M and M is a way to remember this, that the means are the middle two, M and M. Flip the page. Okay, related to the means are what we call the extremes of a proportion. The extremes of a proportion are the first and last terms of a proportion. In fraction form, this would be the top left and the bottom right. So the extremes would be A and D. In colon form, the extremes are the ends, the outside two, which are 3 and 5. Now, a way to remember extremes, E and E, the extremes are the ends. The means are the middle, the extremes are the ends. Pretty easy to keep straight. All right, Roman numeral 2, properties of proportions. Let's start with the means extremes property of proportions. This property says the product of the means is equivalent to, and equivalent means equal to, the product of the extremes. So looking at the proportion A over B equals C over D, the means, or the middle two terms, are B and C. And the extremes are the ends, A and D. So using this property, we can set up an equation, mean B times mean C. So B times C is equal to extreme A and extreme D, A times D. Product of the means, product of the extremes. Okay, example 1. Rewrite 5 over h equals 4/3 using the means extremes property to solve for h. I actually like to put things in colon form. 5 colon h equals 4 colon 3 because I find it's easier to remember. The means are in the middle. The extremes are on the outside. So using the property, the means multiplied together, so 4 times h, are equal to the product of the extremes, which is 5 times 3. I just find colon form just a little more convenient. And then, of course, that's something eventually that you could solve. H ends up being 15/4. Okay, so another application of the means extremes properties is to explain why A over B equals C over D is equivalent to B over A equals D over C. Notice that A over B is flipped to be B over A. That's the difference. So how does this property explain this? So the property states that the product of the means is equivalent to the product of the extremes. So A over B equals C over D is equivalent to the means. So here's your means, your middle two. B times C equals your extremes, which are A times D. To make the left side of this equation look like B over A, we can divide both sides by C. So let me write that. You have B times C equals A times D. If I divide both sides by C, those cancel, and I have B equals A times D over C. So we're trying to make the left side look like B over A. So to get the A moved, we use its reciprocal, 1 over A, which causes the A to cancel. Now we have B over A equals D over C. So the move to the algebra move so that the A cancels on the right and reappears on the left is you divide both sides by A. And that's how you get B over A equals D over C by using regular algebra moves. So there are some properties like this one that are explainable using basic algebra, or you can memorize the property. Both are good. All right, flip the page. Properties of proportion. There are 4 properties of proportion. It is often necessary to replace one proportion by an equivalent proportion. Equivalent, remember, means equal but looks different. So any algebraic change in the proportion can be made as needed. The resulting new equation is shown as the statement. And the statement has a reason, so its reason can be given as a property of proportions. So if you're doing a proof and you want to move stuff around algebraically, the algebra in the proof would have this as the reason, a property of proportions. And it's nice because you don't have to be specific about exactly which algebra move got you there. You just have to say it's a property of proportions. Okay, so here's our 4 basic properties, and I'm going to show you how to get to them algebraically so that if you don't have them memorized, you know how to get there. Okay, so u over x equals ut. So I want the u over x to be a u times t. So let me write this a little bigger. U over x equals r over t. So I need to get rid of the x because there's nothing under that one. So to get rid of the x, multiply by the reciprocal, x over 1 on both sides. That will give us u equals rx over t. And then I need there to be a t on the left, so I'm going to multiply again by the reciprocal, t over 1. So the t's cancel. Now I have u times t equals x times r. So if you just do algebra so the lefts match, then the rights will automatically match if it's a property. Okay, we're going to do the same thing with the second one. We're going to make u over x into u over r. So let's do that. U over x equals r over t. So first thing I need to move is the x. So use its reciprocal. So multiply by x over 1 on both sides. That gives us u equals rx over t. I want it to be over an r. So I'm going to multiply by the reciprocal of r, 1 over r on both sides. The r's on the right cancel. And I have u over r on the left, which is what I wanted, and that equals x over t. There's our second property. Okay, third property. I want u over x to be x over u. This one's super easy. So u over x equals r over t is what I start with. And we can just use flippy step to switch the place of the x and the u. So x over u equals t over r. That's our third property. Okay, our fourth property. This one is the hardest one, I think, to figure out why it works. We need u over x to be u plus x over x. All right, so one of the important parts about doing this one is to understand that u plus x over x is really u over x plus x over x, which is the same thing as u over x plus 1. That's how we can get there. So notice the left already has a u over x. I just need to add to it an x over x. So let me rewrite this. U over x equals r over t. So to get this second x, I need to add x over x to the left. And then here's where it's kind of weird. X over x is equal to 1. On the right side, I need it to have a t over t, not an x over x. So I can actually add a t over t because it is also equal to 1. So I've actually added 1 to both sides. It's just one of them with x's, the other one with t's. So on the left, I have a u and an x both over an x. So u plus x over x. On the right, I have an r and a t both over a t. So r plus t over t. So that's how you get to that proof algebraically. On your homework, they're going to have you check properties, decide if it's a true property or not. The way you would check it is force the left to look like the new version. If the right also matches, it's good, it's a property. If the right doesn't match, it's bad, it's not a property. So to prove it, you just have to make the lefts equal and see what happens on the right. Okay, example 2. For an extended proportion, they say a over b plus c over d plus e over f can be rewritten as a plus c plus e plus anything over b plus d plus f, which is equal to a over b. Kind of a interesting thing. Extended proportion is a proportion with 3 or more fractions. All right, so we're going to actually use this property. Here we go. This is our colon form. We're going to use this property to solve for x and y. Okay? So remember that you can take the first two equal to each other and solve. So this would be the first 2. So we can use that to solve for x. 2 over 3 equals x over 6. To solve for y, which is part of the last 2, we can take those 2. So that would be x over 6 equals y over 12. Of course, we would need to have x to do that. And I think that would probably clear it up. Okay, the other one you could solve for y would be the first and the last. That one and that one. So you could also use those pairs. 2 over 3 equals y over 12 if you wanted to solve for y without an x. So what a lot of people do is when they see the colon form, they go ahead and just flip it into fraction form. 2 over 3 equals x over 6 equals y over 12, and then use that form to figure out what their equations need to be to solve. And again, we can take these 2 to get our y. Okay, flip the page. All right, use a property of proportions to complete the statement, given this as our original equation. All right, so these style of questions are the same as these style of questions, and I'm not going to go over everything today. I'm just going to remind you what I already said, which is that if you want to figure it out, you've got to make the left sides match. So if I take x over 7 equals 4 over 2, to figure out what 2x is, I need to make a 2x on the left. So we need to move the 7, so multiply both sides by 7 over 1. That gives you x equals 28 over 2. And then we need to move the 2 over because we need a 2x. So multiply by 2 over 1 on both sides. You get 2x equals 28. And that would be your answer. So basically you multiply in what you need, multiply out what you don't need. Let's do the next one, and then we're going to skip the rest of these. Let's say we've got 2x equals 3y, and we want to know what 2/3 will be equal to. So I need the left to be 2/3. So first thing I need to do is move the x. So I'm going to multiply by 1 over x on both sides. So the x's cancel. So 2 equals 3y over x. And then I need there to be a 3 on the bottom, so I'm going to multiply by 1 over 3, which actually causes those 3's to cancel. Now I have 2 over 3 equals y over x. Y over x being your answer. So I took out what I didn't want, took out the x with the reciprocal. I put in what I needed by multiplying by 1 over 3 on the bottom. Okay, I'm going to skip the rest of these for time. Let's do this last one here, though. It says in the figure, AD over DB equals CE over EB. And then it proceeds to give us some numbers. If CE is 2, E to B is 6, A to AD is 3, DB is what? And that's what we're trying to figure out, is what D to B is. Okay, so the way you figure these out is by, if they give you the ratio, using the ratio. So I've got CE, EB, AD, DB. I pretty much have the ratios here that I need, so I can just put the numbers in. AD is 3 over DB, or sorry, DE, which I don't, oh, DB, excuse me, D to B, which is what I'm trying to find, DB, equals C to E, which is 2, over E to B, which is 6. So that would be your setup on that one to solve. So for the second equation, they've given you different numbers. They've told you that A to B, so from here to here, is 10. D to B is 8. C to B, which is from here to here, is 7.5. And you're looking for E to B, which is X. So in this case, we have to do some subtracting. We need AD. Well, AD is this whole piece minus the DB. So 10 minus 8, that will give me my A to D, over D to B, which is 8, equals C to E. Okay, this is another subtraction one. The whole thing is 7.5. If I subtract X, what's left is CE. So 7.5 minus X over EB, which I called X. That would be your setup for the second one. So sometimes you're going to need to do subtraction. Okay, that is the end of the notes. I hope you have an excellent afternoon.